Hi class, welcome to lesson 49. In this lesson we are going to learn about pH and acid-base indicators. By the end of this lesson, you should be able to use hydrogen ion concentration, pH, or the color of an indicator to classify a substance as acidic or basic. Basic is also called alkali. So many of you have probably seen the pH scale before. The pH scale is a numeric scale that classifies substance as acidic or basic. Acids have a pH of less than 7, while bases have a pH of greater than 7, and water has a pH of exactly 7. pH is the consequence of water forming ions in solution. A very small number of water molecules, 1.0 times 10 to the negative 7 to be exact, or 1 out of 10 million water molecules, ionizes in solution. When water ionizes, it creates one positive hydrogen ion and one negative hydroxide ion. When an acid is added to water, it throws off this balance, creating more hydrogen ions and less hydroxide ions. And when a base is added to water, it throws off the balance in the other direction, causing there to be more hydroxide ions than hydrogen ions. So water is considered neutral because it has an equal number of positive hydrogen and negative hydroxide ions. Acids have a very low potential to attract hydrogen ions because they have lots of hydrogen ions. And bases have a very high potential to attract hydrogen ions because they have so few. Instead, they have negative hydroxide ions that will be attracted to positive. So here you can see a sample of water. Water is a covalent compound and forms very few ions in solution. That's why it is actually a poor conductor of electricity. But every 1 out of approximately 10 million water molecules will dissociate into positive hydrogen ions and negative hydroxide ions. But if the water is pure, the number of hydrogen are exactly equal to the number of hydroxide, creating a neutral solution. Adding an acid to water adds more positive hydrogen ions, thus throwing off the balance. Again, acids have very low pHs, pH of less than 7. Less than 7 means that 6.9 repeating is still an acid. When you add a base to water, the base dissociates into a metal and a negative hydroxide ion. So bases increase the hydroxide ions in the water. This throws off the balance, thus increasing the pH. Bases have high pHs, greater than 7. That means a pH of 7.01 is still a base. So on the pH scale, as you move further away towards lower numbers from 7, you increase acidic qualities, while you move further away towards higher numbers from 7, then you increase alkali properties, or you increase the amount of base. So acids who have pH close to 7 are weak, while acids that have pH far from 7, like pH of 1 or 2, are considered very strong acids. And bases that have pHs close to 7, like 8 or 9, are weak bases, while stronger bases have much higher pHs. So what's important is that you are able to understand that as you decrease your pH, you are actually increasing your hydrogen ion concentration. And when you increase your pH, you're actually decreasing your hydrogen ion concentration, but increasing your hydroxide ion concentration. On the Regents, you will often be asked to compare the hydrogen ion concentration and the hydroxide ion concentration of different solutions. I really like this diagram because it really gives a nice visual that as we have our pH scale, if we draw it into a rectangle and we create a diagonal, we can see that at a low pH, we actually have a large amount of hydrogen and a very small amount of hydroxide. But at the middle pH of 7, you'll have even hydrogen in red and hydroxide in blue. And as pH increases, the amount of hydrogens actually decrease while the amount of hydroxides increase. The pH scale is not a traditional linear scale, but instead is logarithmic, which means that each change in pH value is a 10-fold change in hydrogen or hydronium ion concentration. So if you change the pH from 7 to 6, you are actually increasing the molarity of the hydrogen ion concentration by 10. But if you move to another pH, so you go from 7 to 5, that is another 10, so 10 times 10, so 5 is 100 times stronger, or it has 100 times greater molarity than a pH of 7. If we change the pH from a pH of 6 to a pH of 3, since we are moving 3 places, we will have to go and change our concentration by 10 to the third. Finally, let's see what happens when we increase our pH from 7 to 9. Since this is an increase of 2 pH units, we have a difference of 100 times. A pH of 9 has 100 times less hydrogen ion concentrations than a pH of 7. One way that we can determine pH is using indicators. Reference Table M lists common indicators that we will use in chemistry. Indicators are special substances that change color to indicate the level of pH measured in a system. Different indicators are able to measure different pH ranges. When using Reference Table M, we know that when the pH is lower than the number to the left, then it is the color to the left. And when the pH is greater than the number to the right, it is the color to the right. But if the pH falls between the two numbers, then the color is changing and cannot be predicted. So when we look at methyl red, we know at a pH of 3.2 or lower, the color will be red. And at a pH of 4.4 or higher, the indicator color will be yellow. But at pHs between 3.2 and 4.4, the color is undetermined. So let's look at this example. Here we are asked to use indicators to determine what color will be shown in a solution with a pH of 5.5. When we examine methyl orange, we can see that 5.5 is greater than 4.4. So this solution will be yellow. In bromocresol green, 5.5 is greater than 5.4. So we are going to choose the color to the right, which is blue. Now for bromothymol blue. Bromothymol blue's lower pH value is 6. 5.5 is less than 6. So we're going to choose the color to the left. Bromothymol blue will be yellow at 5.5. Finally, let's consider thymol blue. Thymol blue's lower pH value is 8.0. So at pHs of 8.0 and lower, it will be yellow. since 5.5 is less than 8.0. Thymol blue will be yellow at this pH. This concludes lesson number 49. Make sure you've taken notes and you've written down any questions that you have and you bring them to class. See you soon.